What is up, guys? Fahir here from AwesomeTuts.com. And enough about our enemies because we added like 3,000 of them. What we want to do now is we are gonna create our first level. Now, creating a level is very simple, but it is a little bit time consuming. And let me show you what I mean by that. So we have here our ground that we have resized because we wanted our player to have something to stand on. But now I'm gonna put it back to its normal size, which is, well, this, as you see right here. But I am not gonna leave it like this. In terms of, I'm gonna duplicate it and I'm gonna have multiple of these grounds right here. And in order to do that, this is my advice to you. What you're gonna do is right click and create an empty game object that's gonna be a parent. So I'm gonna position him at 0, 0, 0 for X, Y, and Z. And this is gonna be the ground parent, which is gonna hold all grounds that are in our game. So take the ground, this one right here, and simply position it as a child under that ground parent. Now, what we want to do, we simply want to duplicate it, and when you duplicate it, you hold Command and press D, or Control D on Windows, and then you have two multiple of these. You see, you have two multiple same game objects in the scene. Now, we want to position them like this, right next to each other. So something like this, so that they will form a ground. But also, we don't want to do it like this. You don't want to position like this, then duplicate it, then position this one like this. This really takes a lot of time, even though creating levels takes time, but this really takes a lot of time. Now, before I show you how are we going to do it, I'm simply going to take this ground and let me just position it a little bit lower, something like this. So negative, let's say -5 on the y-axis. Let me see how that looks like. Maybe a little bit lower. So if we go negative, let's say -5.3. So -5.3. Let me take a look at how this looks like. Yeah, this is okay. Or maybe, let's say, something like this. Okay, -5.2. We're going to agree on -5.2. So what we're going to do now, duplicate the ground, and we are going to take the duplicate, and in order to position it right next to each other, when you select a game object, so for example, our ground, you can hold the V key. So it's V, not W, it's V, the letter V, like, I don't know, Victor, the first letter, so V. You hold it, and notice now, let me just select it. And now when I hold it, notice when I go in some corners, you see I'm hovering over, I'm just hovering with my mouse. You see where these two lines go? So I'm hovering at the bottom left corner. These two lines and the rectangle are at the bottom left corner. Same way with the right, here at the middle, here at the top right, here at the top left. Now here, I'm simply gonna zoom in and go here where the top left is, simply select it or simply grab it with my left mouse button click and snap it like this. And this is called a snap tool. So we snap these grounds. So we simply snap them. Let me duplicate both of these now. So I'm going to duplicate both. And yeah, this works like this. So I can now hold the V key and snap it right here. It will snap it right next to the closest game object. So now we have snapped 4 game objects that are forming our ground, and I'm gonna take all 4 of these, duplicate them, and position this right here, and I am going to snap it like this. So now we have the left side of our level. Let us duplicate all of these and create the right side of our level. So something like this, snap them right here, and voila, here we are. So we are progressing with our level, but our level is not only going to consist out of these grounds. Instead, we're going to go in sprites and go into our tile set, and we have all of these tiles. You see here, take a look at the bottom right corner. I have resized the window. So you have even the water. I'm also going to use the water. You have these trees right here. You have these blocks. So let me select all of these. You can mix and match from different tile sets. So you have tile set 0, 1, 2, 3, 4, and 5. Of course, probably we're not going to use anything from the tile set 5 and 4. This is more like for a dungeon level. But an outside level, yeah, this we are also not going to use it because this is like, you know, for some spring or something like that. I have no idea, but some kind of level where you don't have leaves on your trees. But probably we're gonna use something from tile set 2, 1, and 0. I'm gonna use definitely these trees here, these bushes, the fence right here. I'm gonna use the water. So I'm gonna use the water because our player can fall through the water and die, so on and so forth. And you know how you can, well, take different elements from a sprite sheet. So for example, if I want this tree from this tile set, I'm simply gonna set it to multiple. If it's not already set, go into the sprite editor and I'm gonna take this tree. You see, like this, I'm gonna zoom in and I'm gonna slice this tree, something like this, slice it here, slice it up to here, and slice it to here, and here. It's okay, and voila, here is the tree. Now, one thing that we did not talk about that you can also do in regards to slicing is that when you slice a different element, so here this element is sliced, you can select it. You see, it is indicating that we have selected this slice right here, which is slicing this tree. Now we can go here in the name of that sprite. You see at the bottom right corner of this pop-up window, the bottom right corner, when you select here, you see you have the name. So I can name this, for example, tree 1, and I can hit enter and it will name this tree 1. So when I hit apply now here and go into this tile set and, well, want to use that tree, you will see it has a name, tree 1, which is easier for us to use it. And bam, I can put it right here and voila, we have a tree. Now, you are gonna do all of this on your own. Now, don't be scared. I'm gonna pause the video now and I'm gonna create the level and I'm just gonna show you what I did, which elements I put, because as I said, this is time consuming. Do you wanna watch me put one tree here, then duplicate it, put another tree here, then put something here, so on and so forth? It takes a lot of time. I told you or showed you how you can use the snap key to create the grounds. You're not going to use the snap key, for example, for trees, only if you want to place the tree like this. So if you want to place the tree right next to each other like this, then you will use the snap key. But I'm not going to do that because I'm going to have one tree here and another tree here, maybe a different tree over there, so on and so forth. As I said, I am going to pause the video now, create the level, then we will talk about some other things such as how you can affect which sprite is rendered before another sprite. So we will see that in a second. We will also add our background, encode it, and wrap up the video with that. So without further ado, I will stop the video now, create the level, and then bam, I will show you everything what I did for the level. And I am back with our level 1. As you can see, I have a lot of going on here. So what I essentially did is what I have explained a moment ago. So I simply went in our sprites and inside of our tile set, I took different tiles or different tile parts from these images. So you can take the ground, for example, from this image, you can take the trees, you can take whatever you want. And this is simply arranging that in the scene, as you can see right here. So what I did, I put a tree here. You see, I have added or snapped the ground right next to each other. We talked about that a moment ago. I snapped these blocks. So we have here a bonus block. We have a regular block. Here I have added our coins. Also, I have added trees here, bushes, cut trees. I have added here a river or water, and as you can see, the water has a box collider, so you can add a box collider to the water. The best thing to do here is if you want to do everything as I did, exactly as I did, download the complete project and just, well, copy paste all of this right here, but you can create your own levels. I will only say that when the player falls in the water, he will die. So you will add a box collider and tag the water with the water tag so that we can detect that collision. Now, this is a hint for you so that you can, well, when you add water, you will know that the player will die when he falls down. So, yeah, just tag them and add a box collider and make it a trigger. Now, also the coins here, as you can see, let me just find them right here. So we have the ground parent. Let me just find the coin parent right here. Here it is. We're going to select all of these coins and we are going to add a circle collider on the coins and we are going to set them to be triggers and we need to also tag them. So go here, add tag, and we are going to add the coin tag and we're gonna select all coins in our game and tag them with the coin tag. Now you can also add or drag and drop the coins here into the prefab, so we can create a prefab folder for collectible items or something similar name, that is. Drag and drop the coin right here. So we have the coin. Coin is, by the way, animated. You can find all of these assets right here in the project or in the sprites folder, because you have coins. If I go here in sprites, you will have items. So coin here is in items. You're gonna set him to sprite mode multiple, sprite editor, slice him up, and then you're simply gonna drag and drop him and animate him that way. Save the animation in the folder that you want to save. The scale for the coin is 0.4, same as for these blocks. So let me just actually here, why is the scale? Well, it's not important anyways. What I did here is I took the block parent and then, well, changed his scale. So you can just do on your own. You can resize these on your own. For example, this tree here is resized. Scale is at 2 and 2 for X and the Y, because the original size is smaller, and I've just resized it a little bit so that we can, well, have a more live game. You can also resize these bushes, so on and so forth. Also, the block here, the gold one, is also animated. This bonus block, let me just find it right here where it is located. So it's under sprites, and I think it's under tile set. No, player, somewhere around here. You just need to find it right here. So this is a flame, sprites, items, coin. So we have the coin right here. Block, yeah, here it is in the blocks folder. So sprites and then blocks folder, and you have the bonus block. Simply what you're gonna do is slice him up, set him to sprite mode multiple, sprite editor, slice all of these things up, and then you will create an idle animation. So if I select the bonus block, go into the animator, he has this shine animation. Notice now when I run the game, he will shine. You see they are shining, and of course we are gonna slow down the animation in a second. And you have the idle animation. The idle one is this one right here. So when I select the bonus block, this is the shine animation. As you can see here, notice him shining. This is the idle animation. That is when we jump and hit him, he will be like this. So simply create those two animations. We did this numerous of times already with all our enemies, with our player, so on and so forth. So simply, well, what you're gonna do is create those animations. That way you will practice your knowledge. Now, back to the animation being too fast, simply select the block shine here, and let's say I'm gonna say 0.5. So the animation will be 0.5 for our blocks. If I hit the play button now, you will see the animation is not playing that often. So it's not playing like crazy over and over again. So it's simply slower and, well, it's a little bit prettier. Anyways, this is our level right here. As you can see, also these chocolate blocks, they all have box colliders. This right here also has a block collider. What is wrong with my language? So it has a box collider that our player will be able to stand on it. Now these bushes, the trees, they don't have box colliders. For this right here, the cut tree, maybe you can add a box collider if you want the player to be able to jump on it. So you can add a box collider if you like, or depending on what you want to achieve. But as I said, these bushes, the trees, and all of these decoration parts, they don't have any colliders on them. These chocolate blocks, however, do. You can find the chocolate blocks in the tile set. So for example, in this tile set here, they are right here. Let me just zoom in. This right here, you see below the water, that's the chocolate block. You can find all of these parts right here in the tile set, in the, well, these folders right here. And as I said, surprise me, you don't have to do everything exactly as I did. This is how I created my level. This is how I arrange these game objects to look like in order to create that level. Maybe you will create some better levels than me, so surprise me. Anyways, the last thing that we are going to do is that we are going to add a background to our camera. If I go here, this is what we currently see. And if I go into sprites and backgrounds, I want to add this first background, this one right here. This is the one that I want to add. Let me just position him at 0, 0. And this one is going to be a child of the camera. So simply add the background as a child of the camera, and notice this is what we see now. Now, one other thing that I want to talk about is this right here. You see, when we added the background, we don't see our player. What is going on? Well, for example, how we can determine which game object is rendered on top of which game object, because the player is right here. If I turn off the background, notice if I turn it off, you see the player is there, but we don't even see these bushes. We don't see anything. What is going on? Well, the problem here is the rendering order. Now, there are multiple ways how we can fix this. We can use the z-axis, so we can use it like this, you see. When we, well, put the value of the z-axis lower or higher, the game object will be rendered or not. You see, if I take the player, for example, and set his z value, you see negative, and this one is positive for the background, so now the player is visible. But if I put it back at 0, the player is not visible. So think of the z-axis as determination, where you can determine which game object will be rendered on top of which game object. So currently the background is rendered on top of the player. Another way, which is the recommended way that you can do both ways, but if you're using 2D or creating a 2D game, you can use the sorting layer here for the sprites or order in layer. What is the difference between the two? Well, for example, the sorting layer, currently we have a default one only. So if we create another one, if I go here and add a sorting layer and I say this one, for example, is the player layer. And I take the player and I set him here to player sorting layer. Bam, the player is visible. Why is that? Well, these sorting layers determine also which game object will be rendered on top of which game object. The default one, or the first sorting layer here, will be rendered first. The next sorting layer will be rendered on top of the previous layer. So in this case, the player or any game object that is on this layer will be rendered on top of any game object that is on the default layer. If I put the player back to default, he is not rendered anymore. Why did I do that? Well, because you have also order in layer. What is that? Well, we have sorting layers. If we put all of our game objects on a single layer, let's say default, if we want to determine which one will be rendered on top of another one, we can also use order in layer. So for example, the player is also on the default layer and the background is also on the default layer. I can take the player and set him order in layer 1, which means the game objects that are on layers, orders that have lower value will be rendered back, which means the background will be rendered first, and then the player will be rendered second, which means on top of the background, because the player has order in layer 1 and the background has order in layer 0. Just think of these numbers. The lower the number, that game object will be rendered first. Also for the sorting layers, the first layer will be rendered first, the second layer will be rendered on top of the previous layer, the third one will be rendered on top of the other layers, so on and so forth. So we're gonna take the player, and let me just take all of our game objects, which are our enemies. So I'm gonna take the player, we have the snail here. I'm gonna set the snail also order in layer 2. Anyways, the order in layer just needs to be higher than the game object or the ones that you want to be rendered on top of. I'm gonna take the beetle, also set it on 2. Spider, set it on 2. Frog parent, or for the frog, I'm gonna set him on 2. This is just so that we can, well, add these. Let me just hit apply so that all of these changes apply to these game objects prefabs, so that now we can turn them off. I'm also gonna take the grounds, select all of these grounds. They are also on order in layer 2. Take the fence here, order in layer 2. Take the trees here, order in layer will be 2. The player will be on 3 because otherwise these game objects, these trees, will be rendered on top of the player. The bushes will also be on 2. The blocks will be on 2. So if I go here, blocks are on 2. Coins will be also, so select the coins, set them on order in layer 2. Chocolate blocks, same thing, so select them, order in layer 2. So you can use the Z position, you can use the sorting layers, or you can use the order in layer. Now, order in layer works for the single layer. If you take, for example, if I do this, if I, for example, put the background on the player layer and the player, I put him on the default layer, it does not matter if we have order in layer 3 because the default layer will be rendered behind the player layer because it is lower in the hierarchy. So pay attention to this. So we are going to put them on the default layer, which means they are all on a single layer. And now we can order them in that layer. Now, one other thing is that if we run our game now, I don't want the background to look like this. I want the background. You see how large this background is? We don't see all of the details of the background, so on and so forth. What I'm going to do is I am going to rescale the background. And if we go into assets and scripts, right click, create a new folder. This is going to be our background BG scripts like this. Inside of this one, right click, create a C# script. I'm going to call this one scale background. And we are going to attach it on the background like this and double click it. Bam, double clicking it right here. Open it in MonoDevelop. So what are we going to do here? We don't need anything except for the start function. And let me just tag the class. So tag it like this. Hold enter, give a little bit of space. And what are we going to do in the start function? Well, we are going to calculate the width and the height of the game object and also of the camera. So we are going to first get the sprite renderer, which is SR, which is equal to get component sprite renderer. What is this right here? Well, if I go here in Unity and select the background, we have something called a sprite renderer, which renders the background. If I turn it off, you see the image is not now displayed. So these images, the player, the tree, these blocks, the coins, they are rendered with the help of sprite render, which is this component that is attached on the background. So we can get the sprite renderer component as any other by using get component, and we can get some information about the sprite or the background that is added, or the image. We can get the width of the image, the height of the image, so on and so forth. So what are we going to do next? We are going to call out transform local scale is equal to new vector 3 1 1 1. This is just so that we are 100% sure that the initial scale for the background is his normal scale. So 1, 1, and 1 for X, Y, and Z. Next, we're going to get the width and the height of the image. So we're going to say float width is going to be equal to SR, which is the sprite renderer, dot sprite, which is the image that we added, in this case, the background, the bounds of the background, so the bounds, dot size of those bounds, size X. This is the width, which means this part right here. If I go into the scene and if I take my highlight tool, so just go here, highlight tool like this, this is what we're getting, this part right here, because the sprite renderer component has this information. We added this image right here is added in the sprite renderer. So the sprite renderer knows the width and it knows the height of this game object. Now, if we go back here, so we have the width of that game object by using the size and the bounds X. So now we're going to get the float height, which is SR sprite bounds size Y. So we're going to get the size Y, which is the actual height of the game object. The next thing to do is we need to calculate the world width and the world height. So we're going to say here float world screen height, which is going to be equal to camera main dot orthographic size, multiply that with 2f like this. Now, what is this? What is the world screen height? This right here that you see in Unity, all of this right here, you see, this is called Unity World Space. And our camera, if I turn off the background, the camera right here, I will position it later on. Let me just take the camera actually, and I will position the camera at the original position. Don't worry about that. But what I want to show you is the camera is also represented in world units, in Unity's world space. So what are we doing here with the world screen height is that we are calculating the height of the camera, which means this part right here, the height, if I take the highlight tool, this part right here, we're calculating that, but in Unity's world space. Now we are using the camera's orthographic size, which is this one right here, that we can specify in the camera's properties in the inspector panel. The world height of the camera, which means in Unity's world units, is the size of the camera multiplied by 2. So the half of the camera, this right here, the half, this part right here, has size of 5. The whole size, so from here to here, this whole size has a, well, size of 10. Why? Well, because the half is 5 and the other half is 5. Multiply that by 2. So the camera's size, orthographic, and the projection here is set to orthographic, as you can see right here. So the orthographic size of the camera, multiply that by 2, will give us the height of the camera is in Unity's world space. And what is Unity's world space? Well, for example, in the game view, this right here, this is the screen space, and this has a width of 700 or 1280 by 720. So if I go again in my highlight tool, so this right here, this part right here is 1280, like this is 1280, and this part right here is 720. So this is in the screen space, same as on your device. So 1280, 720. But in Unity's world space, the camera, this right here, this part, the rectangle that you see represented with white lines, is not that size, because Unity's world space is different. Maybe in Unity's world space, 100 pixels is 1 unit, which means that 100 pixels right here is equal to 1 unit. If the width of the camera is how much? 1280. If the width of the camera is 1280 and 100 pixels is 1 unit, what does that mean? If you divide 1280 by 100, you will get how much? That is 12.8. So 12.8 is the width in Unity's world space. If the height is 720 and 100 pixels is 1 unit, so that is 7.2 units is the width in Unity's world space. So this is what I am trying to explain to you. So the width is in Unity's world space different than inside of the pixel world space or screen space. So we are calculating here the world screen height that is in Unity's world space, which I have already explained. So we are also going to get world screen width, and that is equal to, because now we have the screen height, in order to get the screen width in Unity's world space, we need to multiply or actually divide the screen height that we got right here. So we need to divide that with the screen dot height and multiply that with the screen dot width. Now this is Unity's world space. So world height, and let me just make it more clear. I'm going to say here world height, and here I'm going to say world width, and here let me just type it like this, just so that this does not get confusing. So world height in Unity, as I already explained, is the camera's orthographic size multiplied by 2. And the width, we need to take the height and divide that with the screen height multiplied with the screen width. Now screen height is the actual width and height in screen space or screen coordinates, which means this one right here, 7 or 1280. So 1280 by 720. When we multiply those two and divide the world width, we will get the, or actually world height, excuse me, we will get the world width of our camera. So the next thing to do is the following, is create a vector3 temp scale, which is equal to transform a local scale. And now we are simply going to say temp scale dot x is equal to world screen or world width. And we are going to divide that with the width of the sprite. And we're going to add to it, let's say 0.1. And temp scale, so temp scale y is equal to world height. Divide that with the height and plus 0.1f. And then simply we need to say transform a local scale is equal to temp scale. So again, what are we doing here? As I said, this is the actual width of the sprite inside of the game. Now again, this sprite or SR, sprite bounce size X, will give us the size of this image. So the background, it will give us the size of the background in Unity's world space. Again, this is in Unity's world space. If I take the highlight tool again, it will give us the width in Unity's world space. So if the width is, for example, 920, that is multiplied or divided by 100 pixels per unit, that means it will be 19.2. So that will be the width. The height, if it's, I don't know, 1080, that means it will be 10.8, because when we divide that by 100 pixels per unit, and how do we know? How do I know that is 100 pixels per unit? If I select the background, you see here, pixels per unit is actually 32. So excuse me, the pixel per unit is actually 32 here, which means 32 pixels is 1 unit in Unity's world space. I thought it was 100 because usually by default it is 100. So let me select all of these here. Yeah, for all of these, it is actually set to 32, which means 32 pixels is 1 Unity world space. Anyways, you get my point. When you divide, for example, 1000 by 32, that number is how many units in Unity's world space we have. So again, going back here, we are getting the width in Unity's world space and the height. Next, we're calculating the world height of the camera. This is the width and the height of the sprite. So the size of the image, we are getting that in Unity's world space. Next, we are calculating, here the world height of the camera. Multiply that with, well, as you can see here, what did I do? Okay, let me just take it back. Anyways, world height is equal to the orthographic size of the camera, multiply that by 2, and I've explained that. Now the world width, we need to take the world height and divide it with the screen height multiplied with the screen width, which is, as I already said, 1280 by 720. Next, we simply take the temporary scale of the background. For the X, that is world width, which is this one right here, and divide that with the width of the sprite and plus 0.1. This 0.1 is just to rescale the sprite just a little bit for 0.1 for, well, aesthetic purposes. You can remove this right here. You can add 0.5 or test it out and you will see the difference. Now for the temporary scale Y, that is world height divided with the height of the sprite and plus 0.1. What will this do? Well, when we go here on the background, we have attached the script. Notice what's gonna do. You see how the background looks now? When we hit the play button, you will see the background is going to shrink a little bit. Okay, let me just go here and see which errors do we have. What did I do right here? I did not add a semicolon somewhere. Yeah, here. So I did not add a semicolon for the temporary scale right here, which was giving me an error. You see, unexpected, we did not add that. Let me clear the console. Take a look at and pay attention to how the background looks now. When I hit the play button, it is going to shrink the background. You see, it shrunk the background a little bit and we have it more visible. You see here, we have it more visible in, well, it is in respect to the camera, because even if we change the size of the camera, if I take the camera and, for example, set the orthographic size to 10, you see now, if I hit the play button, you see how the sprite will resize. Again, it has resized to fit the camera and to show, well, some cool parts of that sprite. And we have explained how did we scale the background. Fahir here from AwesomeTuts.com. I will see you guys in the next video.